Hello everybody, welcome back again. So this is the second part. I don't really know. I've kind of made the videos back to back, so it's kind of like first part, you could say, but I'm actually making it after. It's actually midnight now. But anyways, moving on from that, this is the just aggregate expenditure model video. So before I was supposed to only do the aggregate expenditure model, but then the question I actually chose was on ISLM, so it got like really out of hand. So I've decided to dedicate a video literally just on the aggregate expenditure model and the Keynesian-Cross model. So with this only involves the AD things, so it doesn't involve, it did involve supply for, but anyways, basically what I'm trying to say is that it only involves the goods market. That's it. There we go. So there are three different types. I explained this in the other video, just not very clearly, but I'll show you the general formulas for them now. So yeah, so for the stage 1 or the closed model, without a public sector, basically the equilibrium equation formula, if you must, is this: B1 minus C. Let me just write that a bit more central. 1 minus C, open bracket, alpha plus I. Now, alpha can be reinstated with C. They're the same thing. Alpha basically just stands for autonomous consumption, because, like I said in the other video, you have your multiplier part and you also have your autonomous part. So this is endogenous and this is exogenous. All they mean, they're very fancy words. Endogenous means affected by. Exogenous means doesn't affect, right? Or isn't affected by. So the multiplier affects income and the other components don't affect income, right? That's all it means. So that's why you write it like that. And then your second stage, I'll just put stage 1 like that. Your second stage, which introduces the public sector model, the general formula is this: 1 minus C, then 1 minus T in brackets, alpha plus I plus G. Notice we don't have G minus T because we are not talking about public expenditure. We're not talking about just fiscal policy. We are solely talking about A or AE, which is aggregate expenditure. And aggregate expenditure is basically aggregate demand, and you don't have G minus T in aggregate demand. Aggregate demand is simply C plus I plus G plus X minus M, right? Which is why there's no minus T. Okay, hopefully I've made that clear. So that's the second stage. And then you've got your full model, which is basically stating everything above plus net trade. So it'd be 1 over 1 minus C, open bracket, 1 minus T plus M, then alpha plus I plus G plus X. I'm sorry if you can hear my fan, by the way. I'm actually processing the other video, so don't mind my laptop. I'm sorry if the audio is crap, but anyways. So the reason why this little m, which basically means marginal propensity to import, is plus m, is because, you know, if you do X minus M, which is the net trade from aggregate demand, let's say Y equals here. Let's just literally just do this. Why is it positive M, you may ask? Well, if you plus M on both sides on just this simple equation, you get plus M. So it's because you want to prevent double counting, whatnot, you move this little m, which is supposed to be over here, to the other side, and then when you factor out y and bring it back down here, it's obviously positive. So that's why that is there. So these are your three general equations. If that did not make sense, I highly recommend you going through this topic with a more detailed, like, learn step-by-step video before you watch this, because this is more of just like a reference to if you've done it before and it's just like, wait, what am I doing? It's not really about, okay, so I need to understand this, right? You've understood it, you've done it before, and you just need a quick reference, right? That's what this is for. Anyways, moving on, we can do this question. So the question will basically be, you know, da-di-da-di-da, here's this information here, da-di-da-di-da-di-da. First question's typically, you know, find national income equilibrium, which is by star, which is what we are going to do. So you have y equals e, of course, and we can see here it only goes up to g. There's no x or m, so this is not the full model. This is the stage 2 model. So stage 2 model suggests we have c plus I plus g, only up to g, right? And the reason why we're not just using the general formula to substitute everything in is because, first of all, you lose marks in an exam if you don't show all your algebraic working, and two, because it doesn't always work, because different questions have different variables, have different inputs, have different equations. Like I doesn't have to be 200, it could be some other equation, like here, like disposable income. It could be y minus d. So we have to derive it one by one. So then no matter what question it is, we'll be able to derive, you know, the equilibrium point. Okay, so we have y then equals, because e equals all this, so you'd have to write e again, equals c. So c is given in the question, plus investment, which is 200, plus government expenditure, which is 2,000. All easy stuff, right? This is another case of looking at what your question gives you, seeing, right, okay, we actually have what YD is. We don't need to do any extra BS, right? So you just substitute that in, simple as, which becomes y minus t plus 200 plus 2,000. And oh, would you look at that? There's a t. We're also given t. Don't need to look anywhere else, right? Just for this question. Other questions may be different. I must say, disclaim again, other questions may be different just for this question. Because the question's given us t, we can substitute t in, right? So we've got 300 plus 0.9 y minus 1,000 plus 200 plus 2,000. I mean, you could already, you know, simplify stuff down, but for the sake of explaining, I did not. So we have 2,500 plus 0.9 y, and just to be on the safe side, minus 900. So now we can then simplify it further. Okay, y equals 1,600 plus 0.9y. So this is kind of looking similar to what the general equation looked like before. So you have y minus 0.9y, which equals 1,600. And then factor out y, of course, equals 1,600. So then obviously you get y star, which is 1 over 1 minus 0.9, because you want to show your endogenous part. And then that's multiplied by 1,600, your exogenous part. Okay, so if that didn't make sense, I'm going to do it again. No worries. I'm going to do it in pink. Actually, no, don't like pink. Let's do it in tan. Okay, so if that didn't make sense, what you can do is basically derive everything with the letters. So then you can get the general formula of what basically we got earlier. And then you can sub in the numbers if that is less confusing to you, right? So we'll start right from the beginning. So we'll do y equals, so obviously c, you can't just put c, or otherwise you wouldn't be doing anything, right? So you have to substitute in some values, but I'll explain as I go along. So you have 0.9 yd plus I plus g, because you have your c plus I plus g parts, right? So I'm just going to write that here. This is your c, so it makes sense. And that is basically that, but you've substituted stuff in from the question, right? So what you can do now is, obviously you got yd, we're given yd, you can just substitute that in. So you got 300 plus 0.9 y minus t plus I plus g, right? And then again, you can expand the brackets. So you get y equals 300 plus 0.9y minus 0.9t plus I plus g. Now, do you see where this is going, right? This is basically the same as this down here. It's just in a more longer lettery form. But if it makes sense to you, then use this way. If it doesn't, then use the other way. It's probably easier as you go along. So again, we want to find y star, so we have to put y or isolate y. So obviously we bring this to the other side to get y minus 0.9y equals 300 minus 0.9t plus I plus g. Okay, and then you got y open bracket 1 minus 0.9, which equals 300 minus 0.9t plus I plus g. Then you get y star is equal to 1 over 1 minus 0.9, then 300 minus 0.9t plus I plus g. Okay, and then once you do that, sub in all the values, and then you get 1 minus 0.9 multiplied by 1600. You get the y star equals 16,000. Okay, so either way, you get the same answer, 16,000. Okay, so you can either, I'll just reinstate it, you can either substitute values in as you go along. I prefer that personally, it's slightly quicker. However, you can also do it using just the algebra, just if it makes sense in your head to, like, you know, identify the endogenous parts and exogenous parts. And I just want to mention one thing here, right? So we can see here the from the algebraic part, actually very interesting, that t is actually part of the exogenous part. And you're probably wondering, but I even just said that it's not part of the exogenous part because it's not part of aggregate demand. Well, here comes another thing, right? If in the question, if in doubt, it comes as just a value, then it's most likely a exogenous part, because, you know, it's a constant variable. It's not dependent on anything. It's not like the multiplier where it's dependent on something, right? It's just itself, so it's most likely exogenous. That's the best way I can explain it to my ability, but hopefully that makes sense. So if you had something, let's say, like, you know, t is, this is not part of the question, so let's say t is equal to ty, right? Now this changes totally, this changes the question totally, right? Because the thing is, this t is exogenous, yes. However, the second it becomes little t, it basically becomes the marginal propensity to tax. Same thing with c, same thing with little m. They all are marginal propensity to something. This is marginal propensity to import, this is marginal propensity to consume, right? So all these little values in aggregate expenditure model mean the marginal propensity to or something. So it's like the rate of consumption, pretty much, right? So yeah, that's also another thing I just want to make clear. No, this is not incorrect. It's just the way that it's being laid out, and it depends on your question. Again, it really just depends on the question, on how you respond. The more you practice with these, the better you'll get. That's all I can say, and you'll be just quicker at identifying which ones are which one's endogenous, which one's exogenous, and then, you know, find the multiplier, and then finding, if in doubt, in total, your national income equilibrium, right? So hopefully that made sense. This video did drag on again, but I just wanted to make it really, really clear that it just depends on your question. It doesn't matter whether someone did this for this question or this for this question. Every single question depends on what it is, the variables are, like, as in what the equations are, like the identities are, sorry, there we go. So yeah, hopefully that makes sense. I'm just trying to make that really, really clear out there. It just really depends on the question. Just in this case, the reason why t is part of the exogenous part is because it's a constant variable, right? Okay, so hopefully that made sense, and I'll see you guys later.